Hey guys, welcome back to another video. Today we're doing trigonometric equations. Okay, so we've done a little bit of this so far, but we haven't considered it to the full extent that we could be. So we've been solving problems like this using our calculator, usually using this inverse function. And so we do sine to the -1 on both sides, and then we get a value. Now, depending on your calculator, you might, or whether you're working in degrees or radians, then you will get one solution from it. But, we've previously looked at our sine function, for example, and we found that there's another solution where you do 180, take this, and you get another one, which would be 3 pi on 4. And then due to the periodicity, okay, keeps going around and around and around and around and around, finding more and more solutions every time it goes around that circle, okay? So you've got 9 pi on 4, 11 pi on 4, so on and so forth. And I'll just show you a diagram here. Alright, Desmos, great tool. We've got our two functions, sine of x and a function y is equal to 1 on root 2. So where these two functions intersect is where they're equal. So you have pi on 4, 3 pi on 4, 9 pi on 4, 11 pi on 4, and you'll see that it keeps going, okay? Not to mention it goes in both directions, okay? So it goes into the negative realm as well. Really, unless it has been restricted or constrained by a domain, okay, so it tells us where we actually want to look for our solutions, then there's infinite many, okay? So this is the focus of our exercise today, trying to solve these types of problems, but with a little bit more detail behind them. So first what we're going to do is we're going to look at solving trig functions in a graphical way. So using our graphs, whether it's sketches or using our technology, doesn't really matter at this stage. Technology is going to be easier to make things work for us, so calculators or Desmos or any other graphing software will work. Okay, so we can find where these trig functions cross over. So the first example here, we've got y is equal to tan of x in the domain. The domain is what x values that these exist for. So you're only drawing the graph between 0 and 2 pi. And then use the graph to find the solutions of tan x is equal to 1. So you would sketch your tan value. Okay, my graph's not going to be great. I've already got a backup on Desmos. But you'll see at y is equal to 1, there are two solutions. Okay, both pi on 4 and 5 pi on 4. And a better diagram would look a little bit like this. So the domain is between 0 and 2 pi. We've got both of our functions, tan x and y is equal to 1. And then where these two cross over is where these functions are equal, or the solutions. Okay, so you've got pi on 4 and 5 pi on 4 are my x values for that. Okay, so let's do another example using technology in a different way. Sketch graphs of y is equal to sine x and y is equal to x take 1 to solve sine x is equal to x take 1. So I'm going to use CAS calculator to graph both of these. Okay, both sine of x, oops, and x take 1. Where these two graphs or functions intersect, then we have our solution. So we're going to analyze our graph, and we're trying to find the intersection between here and here. The calculator asks for your lower and upper bounds in case there's more than one solution. So you want to be going around the solution that we want, and there's our value here. X is equal to 1.93, And if you want to change the number of decimal places, you can go into your settings here and change the display digits. So if you want 6, change it to that, and it'll give you more. So that is a couple of examples of solving out graphically. What we now want to work on is solving them algebraically, and this takes a bit more time and effort. But it's going to come back to understanding how the periodicity of our functions work. Okay, so we have periods for sine and cosine at both 2 pi, period, sine and cosine, 2 pi radians or 360 degrees. And so you can add or subtract a multiple of that and get another solution. So we have to pay attention to our domain. I've got an example here. We can have 30 degrees might be a solution. So 30 plus 360 is a solution. Or 30 plus 2 lots of 360 is a solution. Or 30 take 360, again, is another solution. Then you would simplify those a little bit. So period for sine and cosine is 2 pi or 360 degrees, and tan is pi radians or 180 degrees. Remembering that's going to help us get more of our solutions quicker. Okay. Sine and cosine in our unit circle, for the first between 0 and 2 pi, it's going to have two values. Okay, same y or height or same x value will get you there. Tangent's going to have two within the unit circle, but they're always going to be pi radians or 180 degrees apart. So we can just find one solution and then add on a multiple of that, and it'll get us to it quicker. We'll go through examples in a moment. Okay. Where our functions are positive and negative will help. So going back to the unit circle always helps. We've got A, S, T, and C, all stations to central. Okay, remembering that's going to help us, and remembering our acute angles, so 0, 30, 45, 60, and 90 is going to be useful. Anything that works within our unit circle is going to be our acute angle of theta, and then our other solutions, or our solutions will be one of these four usually. So you've got theta, 180 take theta, 180 plus theta, and 360 take theta, and that comes back to our, you might recognize this, and I've later realized it's a bow tie kind of shape. You've got your theta as your acute angle. That's usually what we're working in, and then it's either positive or negative. And then you've got 180 take theta, 180 plus theta, or 360 take theta gets you to each of these 4 points on our unit circle. It's always going to come back to those. Let's go through some examples. Alright, so solve the equations on the domain. 0 less than x less than 2 pi. So x is between 0 and 2 pi, and because of that, we know that we are working in radians. Cos of x is equal to negative 1 on root 2. So we're asking ourselves, first of all, where is cos x negative? Well, it is in the second and third quadrants. We're thinking about these two solutions here, where this line is going to be equal to negative 1 on root 2. Okay, our solution is going to be 180 take the acute angle and 180 plus the acute angle. But what is the acute angle for 1 on root 2 was the other question that we're thinking. Well, cos of x is equal to 1 on root 2 when x is equal to pi on 4. So our solutions for x when it's negative 1 on root 2, okay, this side, quadrants 2 and 3 of my unit circle, is going to be pi take pi on 4 and pi add pi on 4, or 3 pi on 4 and 5 pi on 4. Okay, those are the only two solutions within a full circle, 0 to 2 pi, that we need to be worried about. We do need to name both of those solutions. Just saying 3 pi on 4 is not going to be enough. Okay, you might get situations where it's not exact values, and then we have to go to our calculators. Okay, so we are trying to do tan of x is equal to 1.2. All right, and thinking back to our definition of tan that we've done in another video, we're thinking of an angle that makes our tangent a length of 1.2. What is this angle? All right. And if we inverse, I use the inverse here, tan of -1, tan to the -1 of 1.2, and let's say, yeah, we're still working in radians because of our domain. Tan to the -1 of 1.2 gives us 0.876. Okay, but there's another solution where this happens. Period of tan is 180 degrees, and you might be thinking about this side here. Tan is positive in our third quadrant as well. So we have another solution where we take that and we add pi. That's supposed to be third quadrant here. Let's go back to our calculator. So we'll take that answer and we'll add pi. So 0.876 and 4.018. Yeah, that works. Alright. So those are two solutions there using the period of tan. Okay, example 4. Man, time goes quickly. Solve sine x is equal to -√3 on 2 for 0 less than x less than 360. Now, because our domain is given in degrees, we are working in degrees. Where is sine negative? Okay, sine's negative in quadrants 3 and 4. Okay, and the acute angle that we're working with, sine x is equal to √3 on 2. When does this occur? This occurs when we have, 60 degrees. That's the acute angle. So we're going to have 180 plus the 60, and 360 take 60. So x is equal to 180 degrees plus 60, and 360 degrees take 60, or 240 and 300. Alright, so where is it positive or negative or equal to whatever we are trying to find? Consider the acute angle situation, and then the two solutions in the circle, double checking the domain that we're well within it, and that where there are no other solutions within that circle. So we're good here. Let's keep it going. We've got solve sine of x is equal to 0 for -2 pi less than x less than 2 pi. So we've got a much larger domain than we have before. And so if we think about our unit circle, whereas sine 0, it is at 0 degrees, or 0 radians and pi radians. And then we can add or subtract my period multiple times, okay? This is how I was shown to write it. I'm adding my period when k is some integer, so I could be adding or subtracting multiples of 2 pi. So for example, I could do 0, take 2 pi, okay, and pi, take 2 pi. So we have 0, pi, and we could have 0, add 2 pi. I can add or subtract any multiple of my period, and so my solutions are negative 2 pi, negative pi, 0, pi, and 2 pi. Generally, we try and write them in ascending order, okay, but you might not necessarily do that first. There's another way that you can use your calculators to solve that as well, double checking that it's in radians because my domain is in radians. So I'm solving sine of x is equal to 0, comma x. And then after my solve function, I can restrict the domain of my solutions using this thing. This means for. So solve this for, and I can say between negative 2 pi equals control less than x less than or equal to 2 pi. Okay, so we said for x is between negative 2 pi and 2 pi. We have to use it. Again, you can find it in where the equals is. I know you can't see where I'm pointing, so down here, and using this one. And then it will give you all of the solutions within that domain. Alright, keep going because there's unfortunately more examples and more difficult things to show you. I think we've got 3 more examples. So solve 2 cos x is plus 1 is equal to 0. When you have this situation, you want to try and make this trig function the subject first. So 2 cos of x is equal to negative 1, so cos of x is equal to negative 1 on 2, or negative half. Alright, so we're thinking about where cos is negative, that's over there. Alright, and the acute angle, cos of 60 degrees, but we're working in radians, so pi on 3 is the acute case. So we're doing x is equal to pi take pi on 3 and pi add pi on 3 to get both of these lines in my diagram. That line and that line is 180 take pi on 3 and 180, or pi, sorry, pi plus pi on 3. And so we get 2 pi on 3 and 4 pi on 3 as both of my solutions. And within that domain, full circle, there is only 2. Keep it going. Example 7, we have a situation where the period is changed, okay? So when we are doubling that number in front of x, we're actually halving the period. So for this function, the period is no longer 2 pi, it's actually pi, so it's going to repeat itself every pi radian, sorry. We're in degrees, so 180 degrees it's going to repeat itself in, which changes things a little bit for us. But first, let's make the trig function the subject. Where is sine positive? Alright, that is these 2 locations on my unit circle. And the acute angle case, we've got sine of 30 degrees is equal to a half. So we can also have sine of 150 degrees is equal to a half. So 2x, alright, we're not just thinking about x, we're thinking about what's inside this trig function, is now 30 degrees, 150 degrees. We haven't altered the period until we divide by this 2 yet, because we're adding any multiple to 360 degrees. Alright, so let's consider that we've got 30 degrees, we've got 150 degrees, we've got 30 plus 360, which is 390. got 150 plus 360, which is 510. Let's just go one more just in case. 360 plus 100, sorry, 390, 750. I might have made a mistake there. Let's just double check. 30 plus 2 times 60, 750. Cool. Alright. That's separate, so don't try and get those two confused. And then we can divide by 2 and eliminate anything. So we have 15 degrees. 150 divided by 2 is 75. 390 divided by 2. I get it wrong. 195 degrees. 510 divided by 2. 255. And then just in case, 750 divided by 2 is 375. But that is outside of my domain. Okay, because I only want to go up to 360, so that one's not going to count. Alright, those are the only 4 solutions between 0 and 360. Alright, a little bit trickier, so we needed to go through it. And last one, we have a situation where we've got cos squared of x. Now, why don't we try something where we say let cos of x equal to a. And so we would actually have cos of, 2 lots of a squared, add a, take 1. So anytime I've seen cos, I've replaced it with a. And then what do I get here? Well, this is a quadratic. And so now we're trying to solve a quadratic where we're actually going to be getting something. How do we solve this? Well, using the table is my favorite method. We have 2a squared, which is 2a and a, and we're trying to get to a, -1. We can have +1 or -1. And so we've got 2a take a is positive a. So we have 2a and -1, and a add 1. This is all equal to 0, but a is cos x, so we've actually got 2 cos x, take 1 times by cos x, add 1 is equal to 0. And so we're actually solving 2 problems here. When is 2 cos x take 1 equal to 0? That's my first part of my bracket. Or, on the other side of things, when is cos of x add 1 equal to 0? Because that's my other bracket. Again, rearrange for your cos function. We go half on this side. Cos of x is equal to -1 on this side. We still need to remain within our domain, which I'm not sure that I've given. Let's say that it's between 0 and 2 pi. Okay, where is cos positive? That is in the 3rd and the 4th quadrant, and it's half, so we're thinking of cos pi on 3, similar to a couple of examples ago. So x is equal to pi on 3, and 2 pi take pi on 3, which is pi on 3 and 5 pi on 3. And cos of x is equal to -1 at, -1 is over on this side, so pi radians, x is equal to pi, that's probably it within our domain. So all of our solutions are pi on 3, pi, and 5 pi on 3. Alright, I know there's a lot there, long video, but lots of things to get through. Why don't you try this as the closing problem? Okay, we're going to say that I would like you to try and solve cos of x is equal to 0 for the domain 2 pi less than x, or negative 2 pi less than x, less than 2 pi. Alright, good luck. Let me know if you have any problems, and we'll see you next time.